Do you want to learn how you can build and deploy an API that can work with your DynamoDB database? In this video, that is exactly what I'm going to show you how to do. Hi guys, my name is Sam with Complete Coding, and in this video we're going to be teaching you how to create an API that can get data from your DynamoDB database. In the last video we created a DynamoDB database, but we want to be able to access it from anywhere such as a front end. To do this we need to create a get API. This is an API where we can hit it with an ID and get back the user that has that data stored. So what we're going to do is jump into the code and we'll find out how we can do that. Now that we're back in the code, the first thing we're going to do is have a little reorganization of this Lambdas folder. What we're going to do is split out the endpoints Lambdas from the common Lambdas. We're going to do this by creating two new folders, one called common, where we're going to drag the API responses into there, and one of them is going to be called endpoints. And this get user file is going to get dragged into the endpoints. So now that's done, we can start creating the API for this DynamoDB get endpoint. We can do this by creating a new file in endpoints called get player score. And this is going to be an API gateway endpoint similar to get user. And it's going to use quite a lot of the same code. We're still going to pass up an ID to the path. So what we're going to do is copy from line 11 upwards and use that as the start of our get player score. So we're going to be console logging out the event, checking that an ID exists and setting this ID to be event.pathParameters.id. To make this a valid function, we need to add a curly brace. The next thing we need to do is we need to prepare our get request. To do this, we can say const user equals await dynamo.get, and we're going to be getting by an ID and a table name. If this falls over, we want to make sure that we're catching the error, so dot catch. And the error, what we're going to do is we're going to console log the error. Error in Dynamo get. And we're going to console log that error. And then we're going to return something, but we want to be able to tell that there has been an error. So we're going to return null. This way we can check if user exists. If it doesn't exist, there's been some sort of error. So that's what we're going to do next. So if there's not a user, then what we're going to do is we're going to use a 400 response. So return responses dot 400 with a message of failed to get user by ID. And if there is a user, then we are going to return that user. So return responses dot 200 and we're going to pass back a user. So if we save this, we can see that there are a couple of things that we are still missing. So this Dynamo object doesn't exist, and also this table name doesn't exist. We'll start with the table name. This table name we could just hard code, but in the future, if we change the name of our table in our serverless file, we'd have an API that no longer works because the table name is hard coded. To get around this, we can use environment variables. So we can say const table name equals process.env.table name. And now we can pass in the table name to this Lambda from our serverless file, which I'll show you when we move on to serverless. Regarding Dynamo, we need to create a new common system. So create a new file in common and call it dynamo.js. And inside this file, we need to first require the AWS SDK. This is because this is the easiest way for us to access our AWS resources. So const AWS equals require AWS SDK. And when you're working with Dynamo, you have to use the document client. So for us, that's const document client equals new AWS dot DynamoDB dot document client, and that is called like that. So this is how we are going to access our files and our lines in our Dynamo database. To create the object, we need to obviously create an object. So const Dynamo equals an object. And on this object, we have a get method, which takes an ID and a table name. Inside here, we need to set up some parameters. So there's very specific parameters that need to be passed into the document client. These are documented on AWS, but I'm going to show you what the ones I use. So const parameters equals an object with table name and a key of ID. So you notice here I'm using a capital T, which is why I've put a capital T in the table name, in the parameters that get passed in, and we're specifying that we have a key of ID. Once we've made those params, we can now pass that into Dynamo document client. So we can say const data equals, and this is an asynchronous process looking up into the Dynamo database. So we need to await this, and it's the document client dot get, passing in our params. As well as that, we need to add dot promise, because originally this was written in using callbacks, but adding dot promise to the end of it turns it into a promise, which is much easier for us to deal with. As well as that, we now need to go and handle this. So if there's not any data, then we need to say there has been an error fetching data from the table. So if not data, and in this case, we also need to check if there are items in the data. So data dot if not data dot item. This is because the format of the data that comes back from the document client has all of the results in the item field. If there hasn't been this, then we can throw an error of, let's use backticks here. There was an error fetching the data for ID of, and then we can programmatically add the ID there from, and again we can say the table name here. So that's perfect. If it doesn't get caught by this if statement, we're going to console log the data and return data.item. The last thing we need to do in this file is make sure that we export this Dynamo object. Go down to the bottom of the file and type module.exports equals Dynamo, like that, and save that file. Now we can go back into our player score file and scroll up to the top of the page. In here, we can now define this Dynamo object by requiring it in. So const Dynamo equals require, and in this case, down one file system into common, and then dynamo.js, just like that. So if we save this, we now have responses in Dynamo which are imported from the other files, from the common files. We set the table name based on the environment variable of table name, get the path parameters of ID, we do a Dynamo lookup to get that ID, and if there's no user, we return a 400, else we return a 200. So that is everything done inside our code. What we need to do now is look into our serverless file. So inside our serverless file, the first thing we need to do is set up those environment variables. We need to do this by adding something to the provider, which will add environment variables onto every single Lambda that we build. So we do that by simply typing environment and then listing out the environment variables that you want. In this case, it's table name, and we want the table name to be that DynamoDB table, which is here. We've referenced this before using $self custom.table name, so we're going to copy that and paste that into there. The next thing we need to do is add a new function. So what we can do is find the functions, copy the old getUser function and paste that into here and change a couple of things. So now it's going to be get player score, and it's going to be lambdas dot endpoints dot get player score. We do need to update the original getUser to add this endpoints folder in. And then we also need to change the path. So get player dash score with an ID. The last thing we need to do is to give permissions to the Lambdas to access DynamoDB. If we tried to deploy this as it is, then we'd be hit with errors saying that we haven't got permission to access Dynamo. So what we can do is add a set of IAM role statements to this provider so that every single Lambda that we build has the permissions to access Dynamo. It sounds complicated, but this is how we can do it. So it's IAM role statement, and the IAM role statements are an array, so it's a dash, and we have an effect, and we want to add the ability to access Dynamo. So we need to allow the Lambdas in this serverless project. We then give them an action. This action is an array, and it is DynamoDB :*. So this means we can access DynamoDB and every method on the DynamoDB class. The next thing we need to do is we need to set the resources that this can access. So with this, you can use this to limit really closely exactly what permissions and what access each of these IAM role statements have. In this case, we could say that this is only able to access this one table, but as we may add more tables in the future, we could also say that it can access everything. To do that, you just need to say that you can access star, which is accessing everything. If we save that, and now what we can do is we can run an SLS deploy, which will deploy our new getPlayerScore endpoint, and hopefully we'll be able to access our database. So SLS deploy. This takes a little while to run as always, so I'll get back to you when that is done. Now that serverless has finished deploying our project, we can see there are two endpoints, the old getUser endpoint and also a new getPlayerScore endpoint. What we can do is we can copy this endpoint and head over to a browser and paste it in the URL address bar. What we can do then is go into Dynamo, and in Dynamo what we can do is we can go to our player points table, and in the last lesson we created a user with an ID of 12345. If you've got any other users with a different ID, then you can use that ID. Go back to our URL here and add that into the end of the URL and hit enter, and you'll see that we get a response of user with score 12, ID and a name. So that is our get endpoint created. In this video, we have learned how we can create a get API using API Gateway and Lambda so that we can get data from our database. This means we can use our web front end and get data that we need. To do this, we've set up a Lambda which takes a request and then gets the ID from the request parameters. This then gets passed into our DynamoDB object using a get method. This get method is a custom method written by us, which takes an ID and a table name and transforms it into the correct format to do a request to DynamoDB document client. This is a service on the Aws Sdk, which allows you to interact with your DynamoDB tables. This GET request returns the data, and then our API returns that down to the customer. We've tested it out and it all works. So now you can use this to build new DynamoDB tables with other GET requests. Thank you for watching this video. If you've made it this far, you've probably learned something new. So please give it a thumbs up and make sure that it gets viewed by more developers just like yourselves. And if you want to learn more about serverless and how you can set up a serverless application, then make sure to subscribe down here to make sure that you get notified next time I release a video on this serverless platform. Thank you, and I'll see you again next time.